Today, we're going to talk about landscape maintenance pest control. With this, it's designed for the Nevada Test C1, but can be used for any of the lawn care applications, tree and shrub, any of that we might run into or have to test and certify for. This is not meant to be a standalone. It's going to be a supplement to reading the study guide. So it's going to help combined with what you've learned in your other classes, your other studies, other PowerPoints. You're going to be able to use this and it'll help get you through that particular test that you're going to have to take. One of the things we're going to talk about is pest identification. A number of pests will attack plants, shrubs, trees, and this is a way to go through some of the very specific parts of the treatment and integrated pest management for trees, shrubs, various turf and ornamental type of applications that we might have. So first thing we'll talk about is ways to identify the pests. Before we do that, we have to say what a pest is. In this case, something that's in an area that it's not wanted. So the pests here would be weeds, invertebrates, vertebrates, and disease agents. First thing we'll talk about is weeds. They're broken down into several categories. One of them is the annuals, which do a complete life cycle from seed to dying and producing seeds again in 1 year. Then you have biennials that will go through a seed production, going from seed to a type of plant that will then overwinter and produce its flowering on the second year. And that's considered a biennial. And then you have perennials, which will go through and have their growth through the whole year. Then they'll go dormant until the next year, starting over again. And this will keep going until they're either run out of energy, grow old, or are somehow removed or killed. Another way weeds are broken up is monocotyledonous and dichotomous plants. Monocots are types of plants that are like grasses. All the veins are in parallel. The structure typically has a more fibrous type of a root because they're individual plants. And so they like to spread by various structures and grow. And then you have dicots, which are what you would be considering more often something that you would see as a broadleaf. And a broadleaf weed or plant would be something that then has a singular type of leaf structure that will have multiple veins going in different directions and could have different types, and most often will have different types of leaf structure. So it's not just a straight leaf. It could be multiple branches of the leaf. Could be any number of things, but those are considered dichotomous. Sometimes they'll even have what they call a taproot, and that's a singular root that goes down. Think of a dandelion or something like that. And then you have, how do we identify weeds? Well, there's a number of ways that we do that. One of them is if they do produce flowers, then utilizing the flowers. If not, we look at the leaf structure. Then secondary to that would be the stems and the various ways that the plant grows. And then lastly, what are some of the structures that might be there? Does it have stems that all the leaves and the flowers come off of, or is it in a bush type structure? These are all things that you'll see better pictures in the manual, but we'll walk through and discuss a little bit more in the idea of how do we identify weeds. So with some of the broadleafs, you're going to have almost what appears to be just a plant that's growing, which is what it is, but it's not one that you want in that area. So you can think of things like the lamb's quarter, the mallow, the dandelions. All of these type of plants would be something that you would look at as being dichotomous, biannual, or perennial weeds. And their structure shows that it has either low-lying multiple leaves that are lobed or that grow up and out into a familiar pattern of a small plant structure that would allow for the plant to receive a number of energy producing UV lights that can then spur on to photosynthesis, as opposed to parallel veined grass-like monocotyledonous plants. Next one we'll talk about a little bit is invertebrate pests. And that would start with the arthropods. And the arthropods are, that means jointed foot. And they're going to be most of your insects or bugs. And there's various developmental stages. There are eggs, larvae, pupa, and adults in a complete life cycle. In an incomplete life cycle, you have egg, nymphs, and adults. That would also be considered a gradual life cycle. You have to be familiar with these in order to determine what's the stage that you want to control. Typically, the easiest stage is going to be when they're larvae or nymphs. The immature stages are much easier to control. Once they're in the egg stage, it's difficult because the eggs are a semi-permeable membrane, meaning it'll allow gases and waste products to come out, but won't allow very much to come in. So it's difficult to control that stage. You also have the pupal stage that has somewhat the same characteristics. It's going to allow for materials to get out, but not get in. So the easiest stage is going to be that environmentally opportunistic larval or some type of nymphal stage. Now, what kind of arthropods are we talking about here? First ones are spiders or mites. Those are arachnids and generally will create issues for the plant, either by choking it off or taking away some of the nutrient value, especially in the case of mites. Mites will cause a problem with the leaves to droop and or fall off. And you can see that it loses its vigor because they're piercing and sucking the juices out of the plant. And when there's hundreds of them that are attacking this plant, it's going to create a very real issue for them. Spiders typically don't eat the plant, but having their webs all over can attract other insects, and that could cause damage and cause issues for the plant itself. Another type of invertebrate pest would be the orthopterans, which would be katydids, crickets, grasshoppers, things like that. And they have a chewing mouth part, which they'll utilize to chew on the leaf blades and also possibly shoots and new growth. And this could be very detrimental to plants. So it's another one of those that we want to really watch for and treat for. Another is earwigs. Again, chewing mouth parts. They'll chew on the leaf blade, new growth, tiny shoots, causing some stunting of the growth and inability for the plant to produce enough energy for itself, ultimately resulting in its own death. True bugs are a group of insects that may prey on other insects that are actually preying on the plant, or if the plant requires some type of pollination or some type of an insect help to be able to go into a different stage or to continue growing, the true bugs can actually be predaceous on these insects and create problems there. The other thing is they can pierce and suck out the juices of the plants and thereby creating a parasitic environment. And then we have our hemipterans, and these are true bugs also, but they're more related to those plant pests that would possibly chew the leaves in addition to piercing and sucking also. And then beetles. They're the largest group of insects that we'll run into. They will sometimes eat, sometimes attack by piercing and sucking. So a whole variety of things that beetles will do to plants that will reduce their ability to continue their lives, either by producing energy and or eliminating their structures by chewing and feeding on them. And then we have moths. And moths typically themselves are not the problem. It's again that larval stage. If you go back and look at the true bugs, the hemipterans, the beetles, moths, all of these insects at their larval stage or their nymphal stage will create issues by feeding on the plants. And then you have stinging insects, which obviously could create big problems, especially if they have large nests or are maybe needed to be able to pollinate. And if they're not around because of some other issue, they're not able to pollinate and generate any type of new plants. So from the standpoint of pest problems that you could run into for weeds themselves, or for any type of ornamental and turf plants, you're going to see weeds, which could choke off the plant's ability to use resources because the weed is attacking the resources too quickly. They could take over a good environment, good ground by choking out also the desirable plant. And then you have invertebrate pests that could attack and eat or destroy the plant by altering its structure so that it can't continue its growth. And then we have diseases. Some of the insects that we deal with could also transfer these diseases. So you'd have bacteria that typically are single-celled and then grow and group and will attack the plants, causing issues there with their inability to process food or energy, or actually take that food and energy away from them. Viruses, which can do the same thing, and funguses, which literally will live on the plant as a parasite. Think in this case, molds or mushrooms and things like that. And then lastly, rodents and birds. As far as pests go from a landscape area, rodents will get into the ground and they'll go underground and chew on some of the roots and some of the growth. They'll also run on the top and eat any kind of new shoots, any new growth that might be occurring there in the plants. And then birds will eat the seeds and create issues there by spreading the seeds into other areas and increase the amount of the plants and the weeds that we might be seeing in various areas. So altogether, the invertebrate, the vertebrate, the disease-causing organisms, and the weeds themselves all lead to basically a disaster in the landscape. If you're looking for good turf, good ornamentals, these are all things that you have to guard against. So how do we manage them? What's the best things that we can do? Well, one is non-chemical measures. What can be done there? Fencing is one. Proper utilization of water. What's the best time to water? The heat of the day, at night, whatever you do could lead to either an increase or decrease in any of those pests that might damage the crop or the ornamentals that you're dealing with. And then what about chemical? Can we apply fertilizers? Can we apply insecticides? Can we use rodenticides? What can be done? And then from an IPM standpoint, What are some of the non-chemical measures that can be utilized from an IPM standpoint that's going to help reduce the need for chemical? And that's the main ways that we would manage these landscape pests. Do we keep the grass cut at the approved level? Do we water in the right amounts at the right time? Is there the right sunlight coming in? Did we recently trim back branches from a tree that opened up the sun and now is causing a burning of the grasses? Is there other things that might have occurred that altered the environment somehow, whether it's increased the sun, decreased the sun, increase the amount of moisture and water that's available, decrease that? All of these things play into integrated pest management program. And if we're going to be using any kind of chemical or pesticide, we have to be aware of a few things. First off, what is toxicity versus hazard? So by toxicity, we mean the availability of that product to cause harm. So the material itself could be very able to cause harm to the organism. And it could be something like botulinum toxin or some type of salmonella from foodborne illnesses. It could be something such as a fumigant. Whatever the material is, it's inherently toxic to whatever the organism is that might be exposed to it. Then hazard is that potential. So you could have something that's extremely toxic, but if it's very low hazard and you're wearing proper personal protective equipment, then there's not going to be that exposure. Or you could have something like table salt, which is relatively low in toxicity. But if you're going to be drinking it or eating it in huge amounts, you could end up in a very precarious situation. So the toxicity and hazard have to be balanced. If it's highly toxic, low hazard. If it's low toxicity, you can increase, unfortunately, for the use of the terms, more of a hazard, but your exposure can be a little more at a lower toxicity because you know that you have that room to be able to be exposed to it without it causing any kind of harm. And then we go into the mode of action of a pesticide. How does it work? Generally, most liquid pesticides are going to be nerve toxins that we use, except for things like a Centria or some type of material that's made directly from plant oils. Everything else predominantly is going to do something to the nerve, whether it's going to be the area between the nerves, the nerve itself, the movement of the electrons. Somehow or other, it's going to create an issue. And one of the modes of action would be, say, with pyrethrins. It blocks the ability for the nerve to get back to a state of relaxation and stableness. It causes it to be constantly moving with that electron flow and exciting their excitability. Another type would be a type of pesticide that might prevent the electron flow from one nerve to another, and thereby creating this movement for the one, but the other's never receiving the signal. So it just continues to fire until that nerve dies. There's other modes of action with drier products that might be more of a mechanical means. And that would be something like if you were to use diatomaceous earth, where it would actually absorb the moisture out of the insect. There's no toxicant there, but mechanically it's pulling the moisture out, and the insect can't live without moisture. And then besides that, within formulations, within pesticides, we have the formulations, and those can be a variety of things, from dusts and granules and baits to aerosols, liquids, microencapsulates, wettable powders. All of these flowables would be things that we might use at different times, and each formulation has a benefit And it also has an issue. So some of the benefits may be that they don't absorb readily into porous surfaces, leaving some material out for the insect. The other thing might be because they're microencapsulates, they might have a much lower dosage of material that's available. Because it's encapsulated, your exposure is very little. So all of these are covered in other sections, other PowerPoints. Be sure to understand the difference of the modes of action and formulations, primarily because both of those change as we end up developing better and better types of pesticides. We're going to be moving into even a more genetic based pesticide that will alter the chromosomes so that maybe the pest no longer breeds or maybe doesn't eat, whatever it might be. We actually have pesticides now that prevent chitin, which is the hardening protein for the insect's body, from hardening up. So the insect stays relatively soft and pliable and loses the moisture out of its body and dies. So there's a variety of things that we have to be aware of, and you'll want to continue looking at as far as types of action the pesticides may be working. This is also considered chemical classes, so that it's another way of just looking at that. Then laws and regulations. These are very important and need to be looked at and understood and read by everybody. The label is considered the law. So under FIFRA, which is the Federal Insecticide, Fungicide, and Rodenticide Act, you're required to follow the label. And both Nevada and Washington and other states are label states, meaning you have to be able to only apply it in areas that it allows. You have some wiggle room, if you will, but you cannot use it in a way that the label prohibits. So you couldn't go into a restaurant and fan spray all of the food areas because that would be illegal. You do have, in some cases, a certain notification that's required, especially when you're dealing with outdoor applications. People may be on a list that requires them to be notified anytime a pesticide is used within a half mile of their house. So be aware that the state publishes that list, and it'll allow you to stay out of trouble, and may also give you the opportunity to address some of the issues. And maybe if you can specialize in that type of program that uses all natural products, as we do, the customer may decide that they actually want to use your service. So it can have some benefits too. And then everything we do needs to be documented, complete documentation. What did you do? What did you find? The whole who, what, where, when, and how. All that needs to be documented, whether it's in the notes, in a separate note to the office. Always make sure the customer knows exactly what you found, what you did, and what you used. And then lastly, one of the other things that's very important is restricted versus general use products. Some products, because of their ability to cause harm to certain animals or insects that may not be necessarily the target species, are restricted because of whatever reason it might be. So we want to make sure that if it is a restricted use product, that we're keeping the correct documentation that then we can provide the state later. If it's a general use product, that could be gotten over the counter, but because you have the knowledge and the ability to provide that service, you're using it in a way that the client may not ever think about using it. Plus, you're using it in the amounts that they might not. Most people have a tendency to try to drown an insect as opposed to treat it in a way that the pesticide itself is going to be working. And some of the hazards that we talked about earlier associated with pesticides. Remember, it's toxicity and hazard. Toxicity being the potential, and hazard being the potential exposure. In this case, human exposure is an issue that we have to deal with. And various parts of your body can be able to absorb pesticides at a different rate. Inner palms, not nearly as much. Ear canals, much higher. Eyes, certain parts of your skin, under your arms, areas where there's a certain amount of oils and or glands that will allow to have that material mixed with oil that will present the opportunity for it to get into your skin. That would be one way. Another is inhalation. You want to make sure that you're always wearing some type of breathing device or mask to prevent any kind of exposure to any harmful viruses, bacteria, funguses, or pesticides. And then the last one will be ingestion. Always wear gloves, always wash your hands, be very careful. You don't want to end up eating the material because of some mistake. Some of the other hazards would be doing an application, accidentally cutting yourself, or not wearing the proper protection and sitting in the material. So these are all things you'd want to watch for, in addition to runoff. If you're doing an application and you over apply, it starts to run down into a drain or some area. Or let's say it's off target drift. You're applying and the application is to one bush or one tree, and you end up inadvertently hitting a couple of others. Probably not going to cause a problem, but potentially there could be an issue, or could end up at a neighbor's property. And then you have what they call chemical trespass. So you want to be very careful, very respectful in what you're doing. And how do we protect people in the environment? One of the things is making sure that specifically, let's say that it's really windy. That would be a hazard for using any pesticide. So you'd want to be careful there, and maybe not even treat. If you're using a particular product that you don't know when you apply it into that crack or crevice where it might go, better to see and investigate where that's going before you apply, so it doesn't happen to open up into a living space or some area where people are at. PPE, we kind of touched on. Always want to be wearing your protective equipment, gloves, goggles, some type of mask, oftentimes a hat, long sleeve shirt, long pants. Make sure that you're completely covered. And then at the end of the day, washing your clothes separately, away from any of the family members, or bringing it into the office and putting it in the bin, letting the uniform company actually take care of that for you. And then handling pesticides. Anytime you handle pesticides, you should have gloves and it should have your mask and glasses on, especially if you're handling the products and mixing them. Accidents happen, wind suddenly kicks up, stuff moves, shifts, could end up splashing. You don't want to end up having any of these things getting into your eye. So you always want to be ready to handle them in the same area, same way every time. So if you're mixing at the back of your van or truck, something splashes in your eyes, you should have some type of water or material right there that you can just reach for and then start to rinse out your eyes. Don't want to have to run around the truck to figure out where it's at. So the closer it can be to where everything's available right there to be able to utilize if you do get exposed, the better it is. And then clean up and disposal. Since we are dealing with 25, 50 gallon, sometimes bigger tanks, that could pose the problem for a lot of material to get out if there should be a leak or a break in a line. So one, know how to shut everything off. Be aware of where the valves are. Be aware of how to crimp the hose. Be aware of how gravity may affect it. You might shut everything off and yet gravity is still pulling everything to the bottom, and that's where the crack is, and so you still have a leak. Make sure that you understand how to contain it. Where do you have your soak up? How do you place it? What's the amounts you put out? If in doubt and you're not sure how, if you can drive within just a short distance to a place where it's an area like grass or gravel, we can always replace that. It's easier to be able to have the material as you're trying to work with shutting everything down, be over an area that we can just get it soaked up and we can replace. Much of the material, in fact, almost all of it, if it gets into a lawn, is not going to harm the lawn. If it gets into gravel, it's not going to hurt the gravel. We just want to make sure that we're protecting everything as much as we can and not putting you at any kind of undue harm or liability. But what happens if we do have an emergency? If we do have something that occurs, make sure that you have all the information with you, what the product is, how much you have in there. Things like, what does the fire department do? Have your MSDS, or now the SDS, is available. If you have a leak or a spill, remember, control it, contain it, and then clean it up. When you got all that taken care of, contact the office to make sure they know what happened and what's going on. Cover as much as you can to make sure that when you do call, you have details that you can give them. When we use the pesticides, we want to make sure that we're effective. And one of the things we have to do is decide, how do we use it? What do we use? Why do we use that particular product? We try to help with that here by telling you, when you're going around with the web brush, to use a dust. And when you're utilizing the dust, we know it's a dry product. We know it's going to spread, and we know it lasts a long time. So we want you to make sure that you're using a product that is not going to have a great deal of knockdown, unless it's Tri-Dye or something like that that has some added pyrethrins. It's not going to hit something and immediately cause them to start falling and running. But what it will do is, over a day or two, kill off the insect, either in this case with the dust, by drying them out, or creating some environment that's not conducive to them staying there. If you're using a microencapsulate, it's going to stay on the surface longer. You won't have as much material that's there, but you could have other issues that you have to watch for. So you want to make sure that you're always aware of what decisions you want to have in line, be able to decide what you're going to use. So it could be you're applying on a porous surface. You want to look toward wettable powders and microencapsulates. If it's an area that's a larger volume and you're not so worried about it getting soaked in, emulsifiable concentrates might be your best bet. And then if it's going to be something where you want to cover a really broad area, but you're not too worried about getting it deep into the surface, you might use granules, especially if it's porous. So everything comes into play, and you have to know what you're trying to treat, why you're trying to treat it, and how you want to get the result, and then what length of time you're looking for. And then when you're choosing, say, some type of a product that might attack certain types of weeds, then you're looking at selective versus non-selective. A selective type of a pesticide is going to be a pesticide that is known to treat broadleaf weeds, but not so much monocots. Or maybe it'll work better on grasses, not so well on broadleafs. Maybe it works at the initial time when you apply it, so it's a contact, but it doesn't have anything left over after 24 hours. So these are all things that you have to decide, and you have to really understand and know the products before you apply them. You can't just grab something out of the truck, put it into a tank, and start spraying. You want to make sure that it's a purposeful, science-based decision. And the equipment. What type of equipment are we going to apply? Are we going to be using the web brush, putting dust on it? How much dust? Are we using the duster? Or are we putting it directly into the container and getting dust on it? If we're going to be using a compressed air sprayer, what size? How much material do we need? How much do we want to put out? Do we want to keep refilling? Do we have available a 2-gallon, a 3-gallon, 25-gallon power rig? Do we know what to do if they break? So these are all things that we have to be aware of, in addition to bait stations, things like that. So all the pesticides, we have to be respectful of the equipment and make sure that we understand exactly how much is being placed out. How do you calibrate what's going on with the power rig? Well, take a 5-gallon bucket and mark off the 5-gallon mark and start applying. The length of time it takes for you to apply 5 gallons, you can be able to understand when you go to somebody's house, if you're applying for that amount of time, you got an idea that you put out 5 gallons. So let's say that you're placing out, put it in a gallon jug, and you're placing out about a gallon a minute. That means if you're applying for 10 minutes straight around that house, chances are you're applying somewhere between 7 and 10 gallons. You always want to be aware of how much is coming out of that nozzle, no matter what, because certain types of pesticides will require you to only apply up to a given amount. So you want to be aware of that. Best way to do that is once a week, take the material, treat a gallon jug, and then see how much you get in 30 seconds or how much in a minute. That way you can be able to calibrate the material to increase or decrease the pressure, increase or decrease the flow, and that'll allow you to be able to control more of how much is actually coming out. And the last thing on equipment, got to keep the equipment clean. Got to be careful of how you're placing the equipment in the truck. You don't want to pinch hoses and then have them start leaking, or have problems with nozzles or bolts and gaskets and things like that. All of that has to be taken care of. And you want to make sure that you're constantly looking to clean and replace whatever you need, because you're only as good as the equipment that you're using out there in the field. And so you want to make sure all of it is taken care of, and you respect where you place it, how you store it, and make sure that when you turn it over to somebody else, it's already cleaned and good to go. So what are some of the ways that we have safe and effective applications of products? How do we apply? You got to know that. You got to know how you want to apply and how this is going to be, this area is going to be treated. You have to know what you're putting out there. What is the product? And why are you using that product? And then what is the insect? What's the target? What's the result you're looking for? Where are you going to place this? Where are you going to have the best effect? Applying at a back fence is going to take care of the pests that are trying to crawl, trying to land out there and get in. But if they're already in, it's not going to have much effect, preventing them from getting to the house. So you want to make sure where you're applying is going to be good for not only the environment, but not an over application. And last thing, with any application, especially with integrated pest management, you want to answer the why question. Why are you applying that material? Why did you choose that material? Why are you putting it in that area? Why are you treating for that particular pest? All of these things come into play, and you have to be able to answer them, even if it's just in your head, because then you know you can justify what you're doing. The most important part that we can come up with is justifying the application. Whenever you're going to be making that application to the customer, they're having that trust in you and your ability to know the details of the pest, the details of the location, the details of everything, so that you're protecting them. And that's our ultimate goal. Make sure they don't have any pests, and that they felt that we gave them a good service by applying the materials in a way that's going to be good for the environment and good for them.